Hi, we're going to talk about a linked list that can store data now. Because, well, a linked list that cannot store data is just not useful. So, like what we did before when we were working on the linked list based stack, is that we are going to create a new class called data node that inherits from the node class. So it has a .next attribute already. And on top of that, it adds a data attribute. So when we initialize the data node, we stored a piece of data in the data node. Now, and for the string method, we no longer need to print out the ID of a node because the data or the string representation of it should clearly tell us what is in a data node. The next thing we want to do now that we have a data node is to write a linked list or data linked list or data list class that would inherit from linked list, which instead of dealing with nodes, that was the job of the linked list class, but the data linked list would deal with or manage data. So here is the data list inherit from linked list, and we would override the two methods that the linked list has. Right, the first one is add to head, but instead of adding node to head, we will now add some data to head. Now, and we would use the linked list add to head to help us to do the job very easily. But remember, linked list add to head, it adds a node to the head. So we have to then wrap the data in the data node and then ask the linked list to add that data node to the head. Very similarly, for the remove from head method, we should return the data at the head or at the first piece of data from this method. So first we would ask the super or linked list remove head to give us the first node that contains data, and then that should be a data node that we added previously, right? And from there, we would extract the data attribute and returns that from this method. So that's what this method. So these two methods, each of them is just one line. And again, they manage data, they add data, and they return data instead of adding node and returning a node. Now, as usual, there are potentially corner cases in these methods. And specifically, I'd like you to think about remove from head. What is the corner case and what happens in that corner case? So please pause the video and think about that for a moment. And I hope you see this, that just as before, if the list of empty, something different is going to happen. So what would happen in this case is that if I just instantiate an empty linked list and then I just remove from the head from the empty linked list, and that would raise an exception. And the reason for that, if we look inside remove from head, is that we assume that there is always a node, right? The linked list would always give us a node, which is not necessarily the case if the linked list is empty. So, and in that case, if you remember, this returns none, and we're trying to do none.data, then we have this problem here. Now, we could, again, try to check for if the node returns it's a none, and if not, then we could, I don't know, return none or do something. But in this particular case, I'll just leave the behavior so that it actually raises an exception in this case, because, well, if you're trying to remove something from an empty list, you probably doing something wrong. So it's raising the exception is a way of telling the client that something goes wrong. So the only problem, I guess, with leaving it this way is that none-type object has no attribute data. That's a little cryptic error message. So we can do better. We can give a more descriptive error message, but the end result is the same. That a exception is raised when we're trying to remove from an empty linked list. So now with this question out of the way, we can actually see how we can use the data list to store data, such as numbers. So here I have a list of numbers, and I instantiate a data list, and I insert all the elements from the linked list. I add all of them to the head, and then I print out the list, and then I will remove each one of them and then print them out. And the reason that I put this in a try and except is that when I'm done removing all the elements from the data list, and I try to remove one more time from an empty linked list, an exception will be raised, right? And I use that exception to know that I've reached the end of the data linked list, and I can break out of the loop. So let me run this, and there we go. So the data in the linked list is, well, 55, 33, 88, 99, and 66, and it is in the reverse order from the original list because every single one is added to the head, right? So this kind of works just like a stack, and that's for the insertion to the head to the data linked list. And for the removal, we remove from the head first, obviously. So 55 first, and then 33, and all the way down to 66. And we successfully ended this loop by, again, handling the exception that is raised when the linked list is empty. So far with the add to head and remove from head, we basically re-implemented the stack, but this time just with the header node. So nothing is really new as far as the client code is concerned, but I assure you that we have laid the foundation to do something more interesting, which we'll get to in a separate video.